20 minutes. Hello and welcome back to Calculus 1. Not sure why I'm excited. I shouldn't be. It's a review. But then maybe you'll ask some questions, so I get to do some math, right? So, exam 2 is on chapter 3. Do you want to add anything to the mix from other chapters? How about mean, max, first derivative test, second derivative test, graphing functions? Any of those things? No? So chapter 3, 11 sections, it's enough, right? Okay. So what do we have in chapter 3? Well, obviously we have the limit definition of the derivative. So you should expect to use limit h goes to 0 of f of x plus h minus f of x over h, right? So at least one of those problems. And now take the derivative. And now this is pretty much the rest of the chapter, right? Plus the word problems at the end. So what do you have? Take the derivative. You have basic, you have the product rule, you have the quotient rule, you have the chain rule, you have implicit, differentiation, and what else do you have? Trig plus inverse. And logarithmic. So take the derivative. And then we have, let me make sure you see this one, tangent line. And for the tangent line, you can have any of these derivatives in here. Anyone. It could be logarithmic differentiation, could be product rule, could be quotient, could be implicit, it doesn't matter. So for tangent line, any of these to get m slope. And we only have one more, which is related rates. Which is the word problem. And that's it. 4 bullet points. I understand it's 11 sections, but it's 4 bullet points for the entire chapter 3. So, what do you definitely expect? I told you, limit question. Whether it's going to be on a square root or a polynomial function or something. So you use that limit. So mechanics of doing that limit, mechanics are in chapter 2.3 of how to take the limit. But the procedure, the formula that you must memorize and stuff like that, that's all 3.1. Take the derivative. The rest, basic. What do you mean basic? Well, the derivative of constant is 0. Derivative of x to the 7 is 7x to the 6. Right? Derivative of e to the x is e to the x. It's all basic stuff. And then we have product rule, quotient rule, chain rule. You know the formulas for those. Logarithmic differentiation is the procedure. And then you have implicit differentiation, which is you put that dx, dy dx every time you differentiate in respect to y to x. And then at the end we have the tangent line problem, right? Every exam from now on will have tangent line. So exam 2, exam 3, and final. Right? They all have to have tangent line problem. So tangent line problem is the procedure, right? You learn the procedure, you take the derivative, you plug the point to get slope. Now you have a point and a slope, plug all of that to find b, and there you go, tangent line. It's a procedure. And it's red because it's the central problem of calculus 1. Tangent line is the one whose slope measures instantaneous change. As you're getting cooled over through speeding, the slope of the function was the speed that you had. So if you were doing 85 and 65, that 85 is the slope of the tangent line. That's what it is. So we have that. And then we have related rates, which are the word problems. Know your geometry for that. We talked about base times height for volume, area of the base, right, times height. And then if it's spiky, what did we say? 1/3 of B times H. Very good. So we have those. And does anyone know the sphere? 4/3 pi r cubed. It's volume, right? So pi r cubed. So r cubed because it's volume, pi because it's round object, and you just need to know there's 4/3 in front. That's really one that it doesn't really flow with the rest. The rest should all be common sense, right? It's volume, so it better be tridimensional, so it better be cubed, so r cubed. It's round, so we have pi. Anything revolving circles and ellipses and spheres, right, ball, they all have pi. So they're round. The trigonometry with the graphs, round, pi, unit circle, pi. So 4/3 pi r cubed for the sphere, and then you have the basic geometry for the rest.
What is spiky? Square?
1/3 base times height, so cone and pyramids and things like that. So 1/3 area of the base times the height. That was in the lecture notes for 3.11. Now, standard stuff. If the exam is a bit spicier, we'll have the replacement question. The bathroom situation is you go before the test, obviously. No graphing calculators. That's the rule. What else? No formula sheet and all of that kind of stuff. So you need to know all of the formulas for differentiation, rules, procedures for logarithmic differentiation. So if you are to see a problem which has, stuff like, let's say, differentiate 3x squared times the third root of x plus 1 divided by x squared minus 6 to the 5th power. If this is a problem, well, this is clearly done fast and quick and easy with logarithmic differentiation. Well, you can go on and do your product rules and quotient and chain and everything else, right? Question is, a little bit of work or a lot of work, right? But if you see a problem, let's say x to the sine x, well, that one must be done by logarithmic differentiation because there is nothing else that you can do, right? When you have a function raised to a function, maybe you need to write that down. Function raised to a function, f of x raised to the g of x in exponent. It must be logarithmic differentiation because logarithmic differentiation is going to turn that into a product rule and then you can do it. So logarithmic differentiation in that case is important. So this problem is log diff or quotient slash product slash chain. But this one is log diff and that's it. There's no choice. So logarithmic differentiation every time when you have f of x raised to g of x. The way you do it, you set equal to y, then you ln both sides. and then you use the rule which will kick this sine x in front. So you have ln, and then you have sine x ln x. And that's d dx then. So the whole thing becomes 1 over y dy dx is equal to, copy the first, it's a product rule, times derivative of the second, plus copy the second, times derivative of the first. So dy dx alone is y goes on this side, so it's x sine x times sine x over x plus ln x cosine x. And that's the answer. So this question has to be done by logarithmic differentiation. There is no amount of product rules and chain rules and things like that that would do it. Because the logarithmic differentiation is the one that takes the sine x from the exponent and puts it in front for a product. And then you can do product rule. So certain problems have to be done by logarithmic differentiation, and others, right, it's the matter of convenience. You all are familiar with the fact that if you put the work and you mess something up, it's partial credit. If you don't put the work and you have the answer, it's wrong, it's 0, right? That's to be clear. Every other page is going to be blank, it's scrap. The back page is reserved for your beautiful artwork, for poetry, short stories, computer code, whatever else, right? Happen? You can't? I'm here. What do you mean you can't see? Well, you can't see. You can see that. This is the one that is the and whenever I lose the direct one, I have to go ahead and check it. Yeah, I think this one. Order is the way of life. It's not something I'm talking about. 10 questions, some of them, you know, maybe A, B. There's determine, shiny. We have a shiny problem. Let's take a look. So, y equals x cubed over x squared minus 3 to the 4th, and we want to find the tangent line. To find the tangent line, we are going to find the first derivative, so you can write y prime, but it's better if you write dy dx. We can use the product rule, the quotient rule on this one. So x squared minus 3 to the 8th, x squared minus 3 to the 4th, times the derivative of the top, which is 3x squared, minus copy x cubed, and the derivative of this is 4x squared minus 3 cubed. Now, what we can see here is, to simplify this, we can factor out x squared minus 3 to the 3rd power, leaving x squared minus 3 times 3x squared minus 4x cubed when you factor, and you have x squared minus 3 to the 8th power, so some stuff will cancel. Oh, I didn't put the point. The point is 1 and 1 over 16. So, tangent line at this point. Alright, so now this stuff cancels. 8 will become a 5. Over here we distribute. So I have 3x to the 4th minus 4x cubed minus 9x squared. divided by x squared minus 3 to the 5. All right? That's what we have. So now equal to 0. So what do? We solve this equation, right? Sorry, not equal to 0. We have the derivative, and now we plug in 1 to get the slope. So slope is my derivative, dy dx, computed at x equals 1. So this is, right, this is notation to say compute. You put a large vertical line and you put x equals 1 down there. So now all of these x's will become 1s. So this is technically in the numerator just 3 minus 4 minus 9 divided by negative 2 to the 5th power. That's all it is. This is negative 10 divided by negative 32. So 10 over 32, which is 5 over 16. So the slope m is 5 over 16, and I have a point 1 over 16. So to find tangent line, we use y equal mx plus b. We plug in everything we have. So 1 over 16 is equal to, slope is 5 over 16 times 1 plus b. This is becoming negative 4 over 16 equals to b. So b is negative 1/4. So what's the tangent line? It's y equals 5 over 16x minus 1/4. And that's the tangent line. We had to take the derivative here using the quotient rule and the chain rule combined. You could have done implicit differentiation. It's okay. Right? Whatever. And once you have the derivative, you plug in x to come up with a slope. When you have the slope and a point, you can compute b, and then you have the entire tangent line. Anything else? Yes?
So, I mean, in the problem when we're looking for the tangent line, it's clearly advantageous to simplify them because you're plugging them and it just makes that part easier.
Okay.
But for problems where we don't have to do that, do we have to simplify?
You actually don't have to simplify it.
You don't have to.
No.
It makes it easier.
You could have plugged in 1 right here.
I know. But
I wanted to simplify because for me it's no effort.
I
But
guess
then,
what I'm trying to get to is can we leave things unsimplified?
yes. But see, what I said is practice simplifying for chapter 4 when you have to equal it to 0. Equal this to 0, good luck, right?
Right.
Equal that to 0 is a joke because you factor out
There's a chance
x squared.
we'll make a mistake in the simplification and we're not getting any points for that.
Exactly. Yes. Yes.
Practice it at home, but don't do it on the test. Right?
Well, you will need that skill for chapter 4. So practice. You know,
On the test.
yeah. All right. Anything else?
So 10 questions, but there's going to be A, B, C.
Well, some of them will have ABC if you just have, you know, a derivative of pi. You can't really have the entire 10 points for that question.
Are you going to put an extra question or
It's not extra. It's a replacement.
it's not extra? Oh, I'm sorry, replacement.
Yeah, there's no extra. One that I bought in 2004. No. They said no. Really? I have to drive back to home. 0.9? No, 0.5. Right.
One more.
All right, so Thursday, 3:30.
Sure. We'll do another logarithm. By the way, class is over, so if you want to leave, you can. We are going to do another example of logarithmic differentiation as soon as that's fine. Any other questions, concerns while Any looking for a question? Yes. Which one?
Are we going around yeah, that's fine. Hell yeah. We're gonna go to so we need to next Tuesday. Yeah, we can. But I mean, we can practice every test with the yeah. Yeah, let's do that. Alright, sounds good.
Alright, so another problem of implicit differentiation. Sorry, logarithmic differentiation. Got it. Thank you. Alright. So logarithmic differentiation on this one, again, you can do quotient rule and your chain rule and product rules, and good luck if you do that. This problem is clearly designed to be used with logarithmic. So we're going to ln both sides, and we are going to break everything apart. So that's going to be 5 ln x minus ln of 1 minus 10x, you can't break that, minus 1/2 ln of x squared plus 2. Both of these are in the denominator, so they both need to be minus. And now we hit this with the differentiation in respect to x. So that gives us 1 over y dy dx is equal to, and now this is 5 over x minus 1 minus 10x. The derivative of this is negative 10, right? Goes up as a chain rule. And then minus 1/2 x squared plus 2, and 2x goes up because the derivative of ln of f of x is f prime over f. So whatever is in the parenthesis gets copied in the denominator as is, and its derivative goes in the numerator. And this is exactly what I did for both of these. You see the denominator is copied as is, and its derivative goes in top. So now dy dx is equal to, this is y times 5 over x plus 10 over 1 minus 10x. 2 and 2 cancel, minus x over x squared plus 2. The last step is to actually put y for y, which means copy original function. And that's going to be x to the 5, 1 minus 10x, square root of x squared plus 2, times 5 over x, plus 10 over 1 minus 10x, minus x over x squared plus 2, and that's the answer. So this is the full problem on logarithmic differentiation and its use. Now, if you developed your skills up to the point where you can just look at the problem and write the answer, sure, why not?
Why did you go with the first, like the function, like right after dy dx equals the function?
Yeah, because when I took the derivative of this, I have 1 over y, which goes as y, which is this piece. I can do it for hours. I can do it for hours. Stay here.
Yeah, I don't. I practice that on cats, so they lock you sometimes and they go like this, and then I. Any other questions? All right, then that's